Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 16 video on the chapter of probability where I will be solving the multiple choice questions from the MCQ Practice Questions book, which is a supplementary book that comes along with the normal textbook of author RD Sharma. From the chapter of probability, I will be solving question number 1 to 7, and in the next video I will solve the remaining problems. So this video is part of the playlist CBSE Maths for class 9 following the textbook of author RD Sharma. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 16 video where I will be solving question number 1 to 7 of MCQ Practice Questions book from the chapter of probability. Okay, question number 1 says the probability of an impossible event is. So this is a conceptual problem. We know the probability of an impossible event is 0. Because the number of outcomes that are favorable to an impossible event is 0. Event E, if event E is an impossible event, then we will always have based on the empirical formula, we know that probability of an event E is equal to the number of outcomes favorable to the event E divided by the total number of outcomes. So for an impossible event, an event which will never happen in an experiment, the number of favorable cases is 0. So this will always be 0 by n. Whatever the value of n is, this is always equal to 0. Question number 2, the probability of a certain event. Now these are important concepts you must understand very clearly. Certain event means if you perform if you perform a random experiment, all the possible outcomes will satisfy this event. That an event which is satisfied by all the possible outcomes of a random experiment is known as a certain event. For example, if I roll a dice, let's say if I toss a coin and say what is the probability of occurring a head or a tail, obviously it will be 1, because that even when the outcome of a tossing of a coin is obviously either a head or a tail, so that is a certain event. Or let's say I roll a dice and I say what is the probability of coming a number which is the natural number less than 10. Obviously all the possible outcomes which are 1, 2, 3, 4, 5, 6, all these are natural numbers less than 10. So that event is a certain event. So for an event E, if event E is a certain event, based on the empirical formula m by n, the small m will always be equal to the n. That is, all the possible outcomes are favorable to a certain event. So m will be equal to n. So n by n, which is equal to 1. So the probability of a certain event is always equal to 1. Okay, the probability of an event of a trial is 1, 0, less than 0, greater than 1. It is definitely not less than 0, and it is definitely not the probability of an event of a trial is I think less than 0. I think I have copied the question wrong, because it cannot be 1, it cannot be 0, it cannot be, I think the choice D should be less than 1. Let me quickly check. Less than 0, greater than 1. Question number 3, okay. More than 1, less than 1. Oh, sorry. So this was, choice C was less than 1. My mistake. This is less than 1. Less than 1. So obviously choice C is the correct answer. For any event of a random experiment, always remember that the probability is always greater than or equal to 0, and it is less than equal to 1. So of all these choices, you cannot for sure say that the probability will be 1. If it is 1, it will be a certain event, and if it is 0, it will be an impossible event. It cannot be greater than 1. So the only choice that satisfies this condition, that the probability of any event is greater than equal to 0 or less than equal to 1, is choice C. Okay, let's see question number 4. Which of the following cannot be the probability of an event? 1 by 3, we know that the probability of any event is always greater than equal to 0, and it is always less than equal to 1. So 5 by 3 is greater than 1. So definitely 5 by 3 cannot be the probability of an event. So C is the correct choice. Okay. Question number 5. 2 coins are tossed simultaneously. The probability of getting at most one head. At most one head. Okay. So quickly list down all the possible outcomes when two coins are tossed. It could be head head, it could be tail tail, it could be head tail, it could be tail head. The total number of outcomes when two coins are tossed is always equal to 2 into 2 equals to 4. Why 2 into 2? Because the first coin, there are two possibilities for the first coin. The first coin can show up either a head or a tail, and the second coin can also show up either a head or a tail. So for each possibility of the first coin, we have two possibility of the second coin. So it is 2 into 2, 4. Okay, so now which are so let's say event E, we define the given event to be we name the given event to be E, that is at most one head. At most one head. Okay, at most one head, meaning we can have this implies one or two head, the one or two head. So the outcomes which are favorable to the FC means favorable, FCE means the outcomes of all the possible outcomes which are favorable to the event E. I represent that as I said will be it is saying at most one head, at most one head, sorry, this will be at most one head, so this will be 0 or 1 head, 0 or 1 head. So 0 head can will occur when we have both tail, and 1 head can occur when it will be head tail or tail head. So for the event E, small n, the number of outcomes which are favorable to the event E is 3. Therefore, the probability of the event E is m by n, which is 3 by 4. 3 by 4. So the correct choice is B. B is the correct choice. Let's see the question number 6. A coin is tossed 1000 times. If the probability of getting a tail is 3 by 8, how many times head is obtained? So this is based on the frequency and outcomes. So let's say so outcome, when a coin is tossed, the outcome can only be head or tail, and frequency we do not know. Let's say the question has asked the total number of times the coin was tossed is 1000. So the total number of trials n is given to be 1000. Let's say we assume that we have to find how many times head is obtained. Let's say we assume x number of times out of these 1000 trials, x number of trials head was head occurred. So quite obviously the number of times tail occurred out of 1000 trials will be 1000 minus x. So now we can easily say what will be the probability of getting a tail. that is if we toss the coin again, what is the let's say what is probability of tail. This is probability of tail. This is probability of tail, meaning if I toss the coin again, what is the probability that a tail will show up. This will be based on the empirical formula. It will be 1000 minus x divided by 1000, and this probability in the problem is given to be 3 by 8. So we get a linear equation in x. We can easily solve for x. Doing cross multiplication, we have 8 into 1000 minus x is equal to 3000. This implies 8000 minus 8x is equal to 3000. This implies 8x is equal to 5000, and this implies x is equal to 5000 by 8. I think I did something wrong. Let's see. 4 2 2 5 0. Okay. 625. 625. So number of times tail occurred out of 1000 times. 1000 out of the 1000 trials, number of times head was obtained is 625. So the correct choice is C. C is the correct choice. Let's see the next problem, the last problem for this video. A dice is rolled 600 times with the following outcomes and their frequencies. So we know all the possible outcomes of a dice are the numbers 1, 2, 3, 4, 5, 6. And out of the 600 times, the frequencies of all these possible outcomes has been given. The question has asked the probability of getting a prime number. Now, of all the possible outcomes, which outcome is a, so if I say okay, so now event, if I say name the event E to be getting a prime number, meaning if the probability of getting a prime number means that if I roll the dice again, what is the probability that a prime number will show up, getting a prime number. Now I know all the possible outcomes when a dice is rolled are the numbers 1, 2, 3, 4, 5, 6. So, and out of these numbers 1, 2, 3, 4, 5, 6, which numbers are prime? 2, 3 and 5. 2, 3, 5 are the prime numbers. So okay, so if I say, so what will be, so what are the total, okay, so now so getting a prime number, this is kind of a composite event. And what how can I define this composite event E in terms of elementary events? We know that a composite event is the collection of elementary events. And what are the elementary events? Elementary events, if you roll a dice, the possible outcomes are 1, 2, 3, 4, 5, 6. These are the possible outcomes if you roll a dice. Now, okay, let's say I define the elementary events as E1 to be 1 shows up. I define the event E2 to be 2 shows up. Like this, E3 to be 3 shows up. Like this, E6 to be the event 6 shows up. That is, when I roll a dice, the number 1 shows up. That event I am calling as E1. Okay. Now the event E that is getting a prime number is a composite event. So how can we define it as a collection of elementary events? Every composite every composite event has to be a collection of elementary events. Elementary events means all the possible outcomes of a single of a trial of a random experiment. In this case, if I roll a dice, what are all the possible outcomes? The possible outcomes are 6. That is, a number 1 can show up, 2 can show up, 3 can show up, 4 can show up, 5 can show up, and 6 can show up. So how can I, so the E1, E2, E3 up to E6, these are the elementary events. How can I define the event E as a collection of the elementary events? Obviously, since event E is getting a prime number, it will be E2, E3 and E5. E2, E3, E5, the collection of the elementary events E2, E3, E5 is defining the composite event, which is event E, which is getting a prime number. So therefore, the probability of the probability of a compound the probability of a compound event is always equal to the sum of the probability of the elementary events in its collection. So this will be probability of E2 plus probability of E3 plus probability of E5. Now we definitely need to know what are the probabilities of all the elementary events E1, E2, E3, E6 based on the given outcome and frequency. We need probability of E2 from the given table. From this table, we can say using the empirical formula, event E2 is that 2 shows up. So out of the 600 times, 2 is showing up 30 times. So the empirical formula of the event E2 will be 30 by 600. Okay, so this will be 1 by 20. Okay, probability of E3 will be how many times the event 3 occurred in the 600 times when out of the 600 trials of rolling a dice, how many trials the event E3 occurred, that is the number 3 shows up, it is 120. So 120 by 600, this is equal to 3 by 15. Okay. Similarly, probability of E5 will be equal to 50 by 600. This is 1 by 12. Therefore, the probability of E will be equal to probability of E2, which is 1 by 20, plus probability of E3, which is 3 by 15, plus plus probability of E5, which is 1 by 12. So this is LCM will be 60, 3 plus 12 plus 5. This is 20 by 60, which is 1 by 3. So 1 by 3 is the probability of getting a prime number when a dice is rolled. So choice A is the correct choice. So I hope solving these problems from the MCQs practice books of mathematics by author RD Sharma, it will give you some clarity and concept of how to solve this kind of problems based on the empirical formula of probability and all the possible outcomes of a random experiment, the number of trials, and the elementary events and the composite events as a collection of some elementary events, and that the probability of a composite event is always equal to the sum of the probabilities of the elementary events in its collection. So if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will solve the problem number 8 to 15. So please stay tuned for the next video. I'm ending the video here. Thanks for watching, and until the next video, take care and bye.